Hi there, my name's Andy Young and I'm one of the automotive lecturers down at Unitech in Auckland, New Zealand. And this is one of the basic skills videos, just really short videos, just taking little tiny bite-sized chunks of stuff that we tend to, as mechanics, take for granted that we think everybody knows how to do. And this video is going to cover how to do a volt drop test. Okay, now with a volt drop test, basically we look at the voltage difference between one end of a wire, one part of a circuit and another part of a circuit. And you could just hop around with your multimeter, set on volts, and you should get really small readings on the good bits, like the wires and stuff, that shouldn't really have much of a volt drop. They should maintain voltage, you know. The less the volt drop, the better for that kind of stuff. And then you've got your consumers in the circuit, things like bulbs and things. Well, they should have a really high volt drop. That's where the majority, if not, well, you're not going to get all of it there, but that's where the vast majority of your volt drop should be occurring at the consumer. And that means that the bulb is going to be nice and bright. If you've got a really dull bulb, say on your trailer, you do a volt drop test from start to finish around that circuit, and you're supplying, battery voltage. Say you've got the car running, so the alternator's fired up, it's knocking out 13.5, 14.5 volts at idle. Who knows? You can test it. Then ideally you should be getting the vast majority of that voltage at the bulb. But if you do a volt drop test through the circuit, breaking it down to as many points or as many sections as possible around that circuit, and you've got a dull bulb, then you might find that one of the sections on that circuit's got quite a large volt drop, and that's not why, because it's just a wire. What's going on there. And you look at it in a bit more detail, and you'll probably find there's a point of resistance, corrosion or a bad connection or whatever, and then you can fix it, and hey presto, your bulb's nice and bright again. So this is a really quick test. This is doing a volt drop test. Don't be confused with available voltage. We'll do a separate video on available voltage later on. This is volt drop test. Now I'm going to move the camera so you can see what's going on. I've got a bit of a rig set up, and hopefully that's going to show you what I mean. Okay, we've got a really simple circuit set up. You've got essentially, I'm using a power supply, but this is basically your battery, your 12-volt battery. And we've got, going off battery positive, we've got a wire that comes round and it's going to the bulb, and then from the bulb down back to the battery. But we've got an earth strap, and this is the kind of thing that you'd find on a car. This could be a wire that either goes directly to the battery, or it could screw to the body of the car, because the body of most cars is battery negative essentially. It's a negative earth vehicle. And you can see here we've got the wire all frayed out for a particular reason, and that'll become apparent a bit later on. So first of all, we're going to do a volt drop test throughout the whole circuit, just to show you how that's done. And we use our two probes. Okay, and the red probe goes at the start of the circuit, and the black probe would go to the end of that particular section. Now, a section of the circuit is wherever you can get access. So on this particular one, we can put it onto the battery positive terminal, and we can also put it onto the back of the input of the bulb just here. So we'll fire it up, we'll get some current flowing, and I'm not quite going to put it on 12 volts because things are getting pretty damn hot on 12. We'll do it at 10 volts. Just to keep the current flow down a bit. Okay, so we've got here the two probes, positive, the red probe onto the battery positive, and the negative probe onto there, and we've got 0.7 of a volt drop in that wire. That wire is quite high resistance. It's really quite thin, and it's not really suitable for running such a large bulb. The volt drop then, we had it on here first of all, that was 0.7. Now we move across one section, so we go on to the black one goes onto the output of the bulb, and the red one where the black one used to be. And we've got 7.7 volts volt drop across the consumer. That's where we really want the bulk of the volt drop to be, across the consumer. Okay, so that was the position there. So now we go red to where the black was, and the next connection in the circuit is, is here. And it's not really connected very well. Again, we've got 0.75 volt drop. Essentially the same size test lead as before, so we'd expect to see about the same volt drop in that one as well. Okay, and then leapfrogging across, red one to where the black one was, and we can go to the end of our earth strap this time on here, look. And oh, that's pretty good actually. We've got very little volt drop. We've got 0.017. So this is a much thicker section of wire to what we've got inside there. Much lower resistance wire, and therefore we're getting much less of a volt drop. And then finally, leapfrogging once more across. So the positive is on the end of our earth strap, and then the negative is on battery negative. We're getting again about 0.76 volt drop. So those volt drops around this circuit are very high, other than this decent bit of wire here. And that's because all these little test leads are really actually getting pretty hot. And that's because they're essentially a very thin section and have a reasonably high resistance for this particular kind of task. They're way under spec for this kind of job. Now, what I'm going to do next is just permanently attach this voltmeter onto this section of wire here. And there we go. Okay, and we have that very low volt drop. Now, as I start to cut sections of that wire, once I find my snippers, which are somewhere, there they are. I've already used them. Right, let's supplement that. There we go. Hopefully you can still see that okay. Yeah, there we go. Perfect. Okay, so as I start to cut through strands on this particular wire, that's going to increase the wire's resistance, and as that happens, we should see the volt drop increase. Yeah, 0.14. I'm not doing one strand at a time. 1.6. Let's just get those out of the way. And this is really represents very much what you'd come across on a vehicle. Now, I've got to be careful because these wires are going to start to get hot soon, and it might be that we get down to one strand and it may actually start to glow. We'll see. Just separate those out again while I've still got a chance. Okay, it's not often we do demonstrations, but it's pretty good. Students like demonstrations. So we're at 0.02, still a lot less volt drop than we're getting in these cables here that form the main circuit. Coming from this side, it's maybe a bit easier. Okay, you can see the volt drop is now increasing. 0.32. Things are going to start to warm up soon. Let's pull those back out of the way. See, we've got probably about a third of the strands left, and we're now up to 0.4 volt drop. Now remember, on these we're about 0.04. On these we're about 0.7, so there's hardly any wire inside those at all. Not really meant for this kind of thing. Okay, so there you go. Look, we're getting pretty thin on the ground now for these strands. So I just want to start to do these one at a time, because it's going to make quite a big difference. So we're at 0.06 near as, damn it. And let's just knock those two out. There we go. 0.07. So that's still a 10% the volt drop that we're getting these. So there really can't be many wires in there at all. Okay, and another couple. There we go. Oh, 0.09. Okay, 0.1. 0.12. Not many strands left now. Okay, we've got 3 strands remaining, and we're at 0.15 volt drop. And you can see that as these strands are becoming less, we're using a thinner and thinner wire essentially. There's less strands for the current flow to go down. We've got 2 left, and we're at 0.25. Now remember, on these ones we've got 0.7. So you know, it'd be interesting to find out how many strands of wire we've got in there. Okay, so there you go. We'll cut the penultimate wire, and we've now lost half a volt drop, and in these we were losing 0.75. So there's basically less than that section of wire on these test leads, which is really quite bad, isn't it? Now obviously once I cut that last strand, we're going to lose circuit and the bulb is going to go out. Okay, here we go. There you go. So we've now lost circuit and essentially there's no current flow, so it doesn't work. Okay, so that was a really simple example of doing a volt drop test around a particular circuit. And if you're doing that on a car, say if you had a really dull, or your tail lights were all dull, for example, on your car, they should be a bit brighter than what they are, then you'd start off at the battery, you'd work your way down to the fuse box where it splits, you'd be checking the volt drop there, checking the volt drop across the fuse, and across the terminals at the back of the fuse box, because quite often there's corrosion inside those fuse boxes, which can cause volt drops in themselves. And then along each section of wire, or the loom that takes that current flow to the rear of the vehicle, to the tail lights, and then obviously down to earth, which then runs it back to the battery. And if you were to, let's say, put the positive on the output of the tail light, so the earth side of the tail light, put one on there, and then put the other one onto battery negative, and you got a large volt drop, then you know that there's a point of high resistance somewhere in the return circuit back to the battery. Now that could be, in actual fact, the contact point where that loom gets its earth, because they don't all go back to the battery negative. Quite often they'll just screw to the bodywork somewhere. You might then find that that screw is corroded, or it's loose, or it's the wire's are frayed, or whatever. Volt drop tests are really useful. They're also really quick, and they're quick to do. They allow you to see where your voltage is leaking away. You want maximum volt drop at the consumer, in this case the bulb. Okay, so I hope you found this really short video helpful, and it is a basic skill. It's something that really you need to get to grips with, of how to use your meters to do various tests. There will be another video covering available voltage, and that's a slightly different test. It sort of means the same thing, but it's a different way of doing it. So I'll do a separate video on that. Okay, thanks for watching. My name is Andy Young. I'm one of the automotive lecturers down at Unitec in Auckland, and I hope you found this video helpful. Cheers, over and out.